In this example, we will apply the ratio test to determine if the series 11 to the k over k factorial converges or diverges. So if we remember, for the ratio test, the process is always the same. We're going to look at the limit as n goes to infinity of the absolute value of an plus 1 over an. We're going to see what happens. If that limit is less than 1, it converges. If the limit is bigger than 1, it diverges. If the limit is equal to 1, we get new information and we need to think about it in a different way. Right, so, an plus 1 means plug n plus 1 in for n. Alright, so in this case, we're looking at k instead of n. That's okay. So it's really a k plus 1. Since k is our index, that will be 11 to the k plus 1 over k plus 1 factorial. And then a to a sub n, in this case a sub k, is 11 to the k over k factorial. So notice what we did. All that we did was take k and turn it into k plus 1, k and turn it into k plus 1, and then the denominator over here is exactly the original terms in the series. At this point, things almost always work the same. This is a fraction divided by a fraction, so we're going to take the bottom fraction and flip it. So this is 11 to the k plus 1 over k plus 1 factorial times k factorial over 11 to the k. Now we do have absolute values here, and that can play a role, especially if there's an alternating series or negative numbers. These are never negative, so in this example I can ignore the absolute value completely. And this is really what we have inside our limit. So we will be taking the limit as k goes to infinity, but before we do that we can do a little bit of simplification here. So notice that generally speaking the simplification will happen along the diagonals here after we flip the fraction. And if I look at this diagonal, this is 11 to the k plus 1, and this is 11 to the k. So I have one extra 11 that shows up in the numerator, and then 11 to the k will cancel out. This is like having 12 k's down here and 12 11s down here and 13 of them up here. All of them cancel except for 1, and that 1 will be left over in the numerator. So I have a single 11 left over. And now the factorials are going to work in a similar way most of the time. This is a k factorial. How do I deal with k plus 1 factorial? Well, k plus 1 factorial is k plus 1 times k factorial. Right? 11 factorial is 11 times 10 all the way down. So I can pull off the very first entry and the rest of them are still factorial. This is k plus 1 times k factorial. The k factorials will then cancel, and that leaves me with just a k plus 1 in the denominator. So I've got my terms, ak plus 1 over ak, and I've simplified it to 11 over k plus 1. We're taking the limit as k goes to infinity of that, 11 over k plus 1. A common error at this point is people look at this and think, well, this behaves like 1 over k, which is a p-series with p equal to 1, so it diverges. But that's not what we're doing. We're taking a limit as k goes to infinity. We're not looking at this as a series. We're looking at this as a sequence and taking the limit. And the limit as k goes to infinity is 0 because the denominator goes to infinity, but the numerator is stuck at 11. So this limit is 0. Once we've taken the limit, all that I need to say is it less than 1, which it is. If the limit is less than 1, that means that the original series converges.